Acceleration is a word that we all have heard before, defined as speeding up or slowing down. It's a change in velocity. We've been dealing with a lot of changes in delta x was our change in position. If we put that over time, that gave us velocity. How quickly are you changing your position? How much time does it take you to change your position? And now we're saying, well, if the velocity changes, which indeed it did in that last example, if that changes, the rate of change of the velocity, we can measure that and call that acceleration. Velocity can change in more than one way. What if your velocity instantly goes from positive 1 meter per second and it changes to negative 1 meters per second? You're still going the same speed, 1 meter per second, but what has changed? Aha, the direction. So a change in direction could also encompass acceleration. So it's the change in velocity over time. And I want you to think about this. What units are we going to use to measure this? Well, the unit of velocity was measured in meters per second. That was on top. And now we're putting that over another unit of time. So notice we have two time units, meters per second per second. I want you to think carefully about what this unit means. It means that every 1 second, your velocity is changing by some meters per second. So every 1 second, you're going 1 meter per second faster, 2 meters per second faster, etc., etc. Another way of writing this is meters per second squared. So here's the example that we were looking at last time. You can see here I have our velocities. So now we could actually calculate the accelerations. The acceleration at the very beginning is going to be 0, as I think you understand. What about for the first second? Remember, we saw that your velocity was changing. It's getting larger and larger, faster and faster. You're moving to the right. I think you can see what the acceleration is going to end up being. Remember, acceleration is the change in velocity over time. Let's look at the acceleration for this first little portion of your journey, for the first second. We saw that you sped up from rest, and by the first second of your journey, you were traveling with a velocity of 0.5 meters per second. So the change in velocity is 0.5 minus 0. Remember, change in is going to be final minus initial. We're looking at this first second. And that took you 1 second. So the acceleration is going to be positive 0.5 meters per second squared. For the next second, what was your change in velocity over time? Well, that time, you ended that second from 1 to 2 seconds with a velocity of 1. You start with a velocity of 0.5, and that took you 1 second. So I think you can see that once again your acceleration was positive 0.5 meters per second squared. And if you keep doing this, you'll see that the acceleration was the same. 0.5 meters per second squared all the way down. What does this mean? Well, think about it. We've already seen it. This means that, remember, meters per second squared. This means that every second that passed, your velocity increased by 0.5 meters per second. From 1 to 2, from 0.5 to 1. From 2 to 3 seconds, your velocity increased by 0.5. From 3 to 4 seconds, your velocity increased by 0.5. From 4 to 5 seconds, your velocity increased by 0.5 meters per second. Every 1 second, 0.5 meters per second, every 1 second, your velocity increased by 0.5 meters per second. That's why acceleration has that funky little squared sign, meters per second squared. Now I do want to stop and say some things about acceleration and sign. What does the sign of acceleration mean? In that last example we had positive accelerations, and it made sense to us that our object was speeding up. That will not always be the case. For velocity, remember we use positive and negative to indicate direction. To the right of the origin, we set as positive. To the left of the origin, we set as negative. Very simple. Velocity sign means direction. What about, though, with acceleration? Well, with acceleration, the sign depends upon the context. Positive and negative acceleration may have different meaning depending on the context. A positive, very, very important, a positive acceleration does not always mean speeding up. And a negative acceleration does not always mean slowing down. Now, how can this be? This time your friend is undertaking the perilous journey to obtain the burrito of the gods, and the data for his journey is over here to the right. Every 1 second, your friend is tracking their position. Looks like, oh man, maybe the gods are after them because they just keep on running past you. They end up back here at -7 meters. Whatever. I'm going to give you a moment to calculate the velocities through. All right, so here you can see my velocities. So their velocity is getting more and more negative. This is the way I would like for you to think about it. Some people would look at this and say their velocity is decreasing because -1, -2, -3, -4. We think about that as a decrease. Mathematically speaking, maybe, but remember what the negative sign means with velocity. It just means direction. So they're actually speeding up in the negative direction. That makes sense. Look at the data. They're getting faster and faster in the negative direction. Let's calculate their accelerations. I'm going to give you a moment to do that. Remember, acceleration is delta V over t. I'll give you a moment. All right, here you can see I've worked the first one out for you. They end this second of travel with a velocity of -1. They began, remember, final minus initial. They began with a velocity of 0. That took 1 second. So their acceleration right here is -1. I think you're going to see that their acceleration is always -1, -2, minus -1, -3, minus -1, all over a second. But wait a second. This is very, very odd. In our last example, we saw that you, over here, when you went this way, that's a positive velocity, that you were speeding up and you had a positive acceleration. This time, your friend going this way, that's a negative velocity, and the acceleration is negative, but we still call that speeding up. How can a negative and a positive acceleration, how can those have the same meaning? Well, remember, it depends on the context for acceleration. Here's the rule. If the sign of velocity and acceleration agree with each other, that means the object is speeding up. If the signs disagree, that means the object is slowing down. So in both of our examples, in the last example, this person moving to the right, that's a positive velocity. Remember, the sign for velocity means direction. And the acceleration was also positive, so that the person was speeding up. This person going to the left, a negative velocity. The acceleration is also negative. Those agree with each other, so this person is also speeding up. All right, I would like for you to analyze this time you moving over to your friend. There's the data. Okay, here you can see that the velocities I've calculated here. You're moving to the right, so the velocities are always positive. But what's happening to them? They're getting lower. They're getting less and less positive, a smaller and smaller positive value. So you're moving to the right, slower and slower. Let's look at the accelerations. This one is a little bit tricky. You start at rest. By the end of the first second, you have obtained a velocity of 2.5 meters per second. So that's an acceleration of 2.5 meters per second squared. Of course, you had to speed up to reach that speed in your first second. But then after that, I guess you spent too much energy. And now, as we said, you're slowing down. 2.5, 2, 1.51. That's a change of 0.5 meters per second every second. Once again, I will say meters per second. That's the unit of acceleration. Meters per second per second. Every 1 second, you are going 0.5 meters per second more slowly. How can we look at the signs and predict that this person is slowing down? The velocity is always positive because that's to the right. The velocity vector, we could say, is to the right. but the acceleration vector is negative. We can almost think about that as if the acceleration is to the left. They are working against each other. The acceleration is backwards. The acceleration is negative. These do not agree. Positive velocity, negative acceleration. That means that this person is slowing down. So I think you've seen through several examples the sign of the acceleration, what it means. It depends on the context. If the velocity is positive and the acceleration is positive, as we've seen, that's speeding up. If it's negative and negative, that's speeding up. But if it's positive and negative, the signs disagree with each other, then that is a slowing down. This velocity is getting less and less positive. It's becoming a smaller and smaller positive number. So here's a summary of that. If the signs for velocity and acceleration agree with each other, the object is speeding up. If they disagree, the object is slowing down.